Welcome to the deep dive. Our mission today is, well, it's a simple one to state. We're investigating the centuries-long quest for an unbeatable betting strategy.
Right.
Can you actually outsmart the math? Or do you have to, literally outsmart the machine?
It's the ultimate conflict, isn't it?
We're going to try and separate the systems that are, well, mathematically doomed from the really rare exploits that actually worked, usually by bending the rules of physics.
And you've laid it out perfectly. On one side, you have the casino, which relies on pure, unpredictable chance. That's their entire business model.
Their advantage.
Exactly, their bedrock advantage. And on the other side, you have deterministic reality, where things like the laws of motion or just tiny manufacturing flaws give a really sharp player a temporary edge.
So for most people, trying to beat a game like roulette with some kind of betting system it's just an impossible fight.
Oh, completely. It's basically like trying to build a financial perpetual motion machine. It just doesn't work.
And there's even a formal statement on this, right? From game theorist Richard Arnold Epstein.
Yeah, his Theorem 1. It essentially states that if you're risking money over and over in a game where the odds don't change,
Like roulette.
Then all betting systems, no matter how clever you think they are, they all end up with the exact same long-term result.
Which is really just a fancy way of saying if the game has a negative expected value,
Yeah,
that house edge, changing how much you bet, is not going to save you.
precisely. Let's, maybe we should quickly define expected value, or EV, because it's the whole game.
Good idea.
So expected value is just the average amount you can expect to win or lose for every dollar you bet, but over a long, long time, an almost infinite number of plays.
So if the EV is negative, the house is guaranteed to win, eventually.
In the long run, yes, guaranteed.
Okay, so let's unpack this with it's the poster child for doomed systems, Martingale.
Of course.
It's ancient, right? From
Yeah.
18th century France. And it's all about creating this illusion of control just by changing your bet size.
The principle behind Martingale is so simple. It feels foolproof. You just double your bet after every loss.
Right.
The logic is that when you finally get a win, that one single payout is big enough to cover all your previous losses, and you still walk away with a profit equal to what your first bet was.
It feels like a sure thing. You can't lose forever, can you?
Well, mathematically, it's useless for making a profit long term. Because doubling your bet, it only changes the size of the transaction. It doesn't change the odds of the outcome.
Every spin is its own separate event.
An independent trial. And this is where the law of large numbers just comes in and crushes Martingale.
Okay, explain that.
The law tells us that while, short runs can be wild,
Yeah.
totally unpredictable, the longer you play, the closer your actual results will get to that theoretical expected value.
That guaranteed loss we just talked about.
Exactly, which means that statistically, that massive, catastrophic losing streak, it will happen. It's not a question of if, it's a question of when.
And when it does happen, Martingale fails because of what you call the triple threat.
Threat number one is just the insane exponential growth of the bets.
Right.
Let's say you start with a tiny $1 stake. After just 10 losses in a row, you've already had to invest $16,383.
Wow.
Just for the chance to win a single $1 profit on that next spin.
The risk to reward is just completely broken.
It's absurd. And that leads to threat number two, the casino itself. They have table limits.
Of course.
Once your next bet, your doubling bet, goes over that maximum limit, you can't place it. The system collapses right there, and you've locked in your biggest possible loss.
And the third threat is the most basic one. It's that negative EV, the house edge.
Always. Even on a European wheel, which has better odds for the player, you have 37 numbers, 0 to 36. But the payout for hitting one is only 35 to 1.
That little gap is where they get you.
That gap guarantees a 2.7% house edge. So your EV is negative no matter how much money you throw at the table.
And that combination, the inevitability of the long streak in the math, that's what leads to the gambler's fallacy,
Wait,
right?
absolutely. The human mind just breaks.
That's the idea that, after 10 reds have come up in a row, black is suddenly due.
Exactly. It's this completely incorrect belief that what happened in the past somehow affects the next independent spin. Our brain just crave patterns and correction. We think a small sample, like 10 spins, has to look like the true 50-50 average.
And we found a really dramatic and recent story that shows this perfectly. An amateur online gambler, using Martingale, of course.
Of course.
He was up a little bit, betting just small $2 stakes on black.
And then red hits once, twice, 3 times.
Sure.
He keeps doubling, as you do.
Yeah.
By the ninth spin, he has to bet $256, then $512 on the 10th.
At that point, he just ran out of money.
He ran out of bankroll, he just couldn't make the next bet, and he had to sit there and watch the streak continue to 11 consecutive reds.
11 in a row. Now, if you just round the odds to 50-50 to make it simple, the probability of that happening, it's not that crazy, is it?
No, it's statistically likely. It happens about once in every 2,000 spins or so. It's not some black swan event. It's a totally standard feature of random chance.
And the really crucial thing for you, the listener, to grasp here isn't the specific math, it's the absurdity of the risk.
Yes. To recover from those 11 losses and make his original $2 profit, he would have needed to bet over $4,000 on that next spin.
$4,000 for the exact same, less than 50% chance of winning he had on his very first $2 bet.
You're betting thousands just for the chance to win back a couple of bucks. It makes no sense.
And this failure is universal. It's not just Martingale. We saw simulations of other systems like the reversal of Boucher.
That's the one where you increase bets after a win and decrease after a loss. It's what Norman Lee claimed he used in the book 13 against the bank.
But the simulations, they don't lie.
Nope. 1.5 billion simulated spins on a European wheel confirmed it. The system still loses money right in line with the house edge. It just can't overcome the negative EV.
So, okay, the math is a dead end. Bet sizing is a trap. What happens when we stop trying to fight the math and instead look for an edge in the physics?
Now that is the pivot. That's where it gets interesting. The only way to win consistently is to actually change the odds of the game.
And you can do that in two ways.
Two ways. You can exploit a static physical bias, or you can exploit dynamic determinism.
Let's start with bias.
Yeah.
The mechanical flaw. And the archetype here has to be Joseph Jagger.
Absolutely, Jagger. He was a textile businessman and a mechanic back in 1881. And the crucial thing is, he didn't see a roulette table as a perfect random number generator. He saw it for what it was.
The machine.
A faulty machine. He knew that no spinning wheel could ever be perfectly balanced.
So he sent assistants to the Casino de Monte Carlo to just record thousands and thousands of spins.
Yep. They found a wheel with a clear, systematic, and exploitable bias. And he just took them for a ride. He won over 2 million francs.
Which today would be worth, what, millions and millions of pounds?
Several million, yes. And he famously broke the bank multiple times, which just meant he won more than the 100,000 francs the table had in its cash reserve.
So how did the casino react?
Well, at first they literally just shuffled the wheels between the different tables each night to try and confuse him.
That's amazing.
Yeah, and later they introduced these movable partitions on the wheels to mess up his observation methods.
And we saw a modern version of this in the early 90s with Gonzalo Garcia Pelayo, a Spanish filmmaker. He basically took Jagger's idea high-tech.
Exactly. He wasn't just looking for an obvious wobble. He used a computer program to analyze tens of thousands of spins, hunting for those microscopic imperfections.
Like manufacturing defects or wear on the drum.
Or loose frets, anything that would cause certain numbers to pop up just a little more often than their true 1 in 37 chance.
And he and his family won huge amounts of money, I think 600,000 euros in a single day.
Yeah, they did. And here's the really important legal point. The casino sued him.
Yeah.
And the Spanish Supreme Court ruled in his favor. They said he had just used ingenuity and computer techniques. He wasn't cheating the math, he was exploiting the physics.
But the problem for anyone trying that today is that static bias like that it's being engineered out of the system.
It really is. Casinos now use their own computers to automatically detect and correct for bias. They use these incredibly advanced wheels with durable metal frets that just don't wear down the same way. The chance of finding a reliable flaw like that now it's close to zero.
Which brings us to the scientific frontier, exploiting determinism. If the static flaws are gone, you have to find an advantage in real time while the ball is actually spinning.
This is where physics becomes the real opponent, even if the wheel is perfectly balanced.
Roulette is uniquely deterministic.
It is. The ball's path, its velocity, its trajectory, it all follows the laws of motion. So, in principle, if you can measure the initial conditions.
Which you can because they let you bet after the spin starts.
Right. If you can measure it, you can predict the outcome.
And this idea isn't even new. It goes way back to people like Henri Poincaré, one of the founders of chaos theory.
He used the roulette wheel as a classic illustration of his concept of extreme sensitivity to initial conditions.
And then, in the 60s, you get Edward Thorp, the card-counting guy, collaborating with Claude Shannon, the father of information theory, on this exact problem.
Thorpe claimed that even a tiny measurement, like a tilt of just zero point 0.2 degrees, could give you a 15% advantage, which he said jumped to 44% if you had a little pocket-sized computer helping you.
The goal was pretty simple, right? Just calculate the speed of the ball on the wheel, predict when the ball would fall, and figure out which half of the wheel it was likely to land in.
And that led directly to the chaos cabal in the late 70s, a group of academics like Doyne Farmer and Norman Packard. They took the theory and they actually built it.
They implemented a fully functional system using a 6502 microprocessor. That's the same chip that was in the Apple II computer.
And they hid it in a shoe.
A computer in a shoe.
A shoe computer, yes. They'd measure the ball and wheel velocity by tapping their toes on switches inside the sole.
And how did they get the instructions?
They got betting instructions via these little tactile pulses, which, according to their own notes, sometimes delivered painful electric shocks when the person wearing the shoe got nervous and started sweating.
Wait, hold on. A computer in your shoe is giving you electric shocks when you get nervous about a massive bet. That sounds like an engineering nightmare.
It was a total nightmare, but they said it worked. They calculated their edge could be as high as 44%.
And this isn't just theory. You had that London Ritz incident in 2004, where a team won over £1 million using a laser scanner and mobile phones.
Exactly. And even recent academic models confirm it's feasible. Research shows a simple system could get you an expected return of at least plus 18%. The physical wheel, even a perfect one, is vulnerable because it's governed by predictable, measurable laws.
The moment we switch from that physical wheel to online gambling, it's a completely different world.
Oh, totally. We leave physics behind and enter the world of computer science, the random number generator, or RNG.
So online roulette uses RNGs. You have true RNGs, which use natural external sources like atmospheric radiation to generate numbers. They're highly unpredictable.
And then you have the ones most systems use, pseudo-RNGs or PRNGs. These are computer programs based on algorithms and internal clocks.
Because they're based on rules, they are predictable. Sort of?
In some ways, yes, if you could somehow get the exact algorithm and enough data. But modern high-quality PRNGs are, for all practical purposes, indistinguishable from truly random ones.
So can you exploit them? The sources seem pretty clear that for a normal player, it's just not practical.
Not at all. It takes huge amounts of data. For a really high-quality PRNG, you might need hundreds of thousands of game results just to find a tiny weakness in its pattern.
And no regular person can get that data without losing a catastrophic amount of money.
Right. The few successful exploits we know about, like with some Russian hacking teams, involve them getting insider info or actually buying the exact same RNG hardware the casinos used so they could test it offline.
Which really just confirms the main point here. The physical wheels that Joseph Jagger and the Chaos Cabal beat were, believe it or not, far easier to exploit than a modern digital RNG.
Because they were subject to the physics of our world, not hidden inside nearly impenetrable code.
So after all this, what's the key lesson for someone trying to understand this unbeatable game?
I think the lesson is that any system focused on just changing your bet size martingale or anything like it is mathematically doomed. The house edge and the table limits will always get you. The system only ensures that when that big losing streak eventually hits, your losses are catastrophic.
The only way to win is to actually change the odds of the game, either by finding a physical flaw in an old wheel, a static bias,
or through dynamic deterministic prediction, like the shoe computer. Calculating the outcome faster than the casino can stop you from betting.
and that ties right back to the law of large numbers we mentioned at the start.
It does. We've established that the gambler's expected value is negative and that over time your results will converge to that loss. But the time scale is just staggering.
How staggering.
Well, think about that simulation we mentioned. It ran 1.5 billion spins to confirm the negative expectation. For a single casino, spinning a wheel by hand 30 times an hour, it would take them more than 5,000 years to reach that number.
5,000 years, just to prove the math is real.
So the final thought I want to leave you with is this. If the long run is a mathematical certainty, but the human timeline makes actually reaching that long run completely impractical, does the sheer staggering length of time it takes to prove the impossibility of winning change how we should think about the impossibility of winning in the short term?